In this question, it is given that the four identical pendulums are made each by attaching a small ball of mass 100 grams on a 20 centimeter long thread and suspended from the same point. Now, each ball is given a charge q so that the balls move away from each other with each thread making an angle of 45 degree from the vertical. Then our job is to find out the charge q on each ball. Just imagine about the situation. Here the four balls are suspended with the help of a thread from the same point. Now if they repel one another, what will happen? They will move away from one another. Therefore, they will form a square, is it not? That is, you can imagine that these are the four balls at the four corners of a square. Now what will be the side of each square? For example, at present, let me take it as A. Then what will happen? The thread is being suspended, and therefore you can imagine that it is forming a pyramid. Is it not? It is forming a pyramid. So that exactly above the center of the square is the point of suspension. Now the thread length, how much they have given as 20 centimeter, and the thread is making 45 degree with the vertical. So this particular is the projection of the thread on the ground, and this is nothing but 20, which is the length of the thread, multiplied by cos 45 degree, that is 20 by root 2. So this is 20 by root 2, this is also 20 by root 2, both are in centimeters. Hence, the diagonal of this particular square is 40 by root 2 centimeters. And if I assume that each side is a, then we can say that a root 2 will be equal to 40 by root 2, which gives a is equal to 20 centimeter. Now this is the square, the placement of these balls which are charged. Now each ball, let us consider the force diagram of any one of the ball. So let's say this one, this particular ball, it is being repelled by these two. So these are the forces F and F, and it is being repelled by this ball which is diagonally opposite. So this is F dash. Now what is F? F will be K, which is 9 into 10 to the power 9, Q into Q divided by 20 into 10 to the power minus 2 square. Please be careful about using the units. 20 is in centimeters. And what is F dash? F dash is the force of repulsion due to the other ball which is diagonally opposite. So this will be 9 into 10 to the power 9 q square divided by the diagonal. Remember, it is 40 by root 2. What is 40 by root 2? It is 20 root 2. So 20 root 2 into 10 to the power minus 2 whole square. Then what's the net force? Just observe, the net force will be equal to the resultant of F and F, which are acting at 90 degree. It will be root 2F, and this F dash is already oriented in that particular direction, that is root 2F plus F dash. Let's put the value. Root 2, 9 into 10 to the power 9 q square divided by, just look at the value, 400 into 10 to the power minus 4 plus F dash is 9 into 10 to the power 9 q square divided by 800 into 10 to the power minus 4. You can take common, and the LCM if you take, finally you have 1 plus 2 root 2, and then it will be 9 by 8 q square and 10 to the power 11. Now what they have given is the mass of each ball is 100 grams. Now what will happen if T is the tension in the thread? The tension will have two components. One component will be counterbalancing the outward force, and another component will be counterbalancing the mg. That is, we can have T cos 45 is equal to mg, and T sine 45 degree will be counterbalancing this 1 plus 2 root 2, and we have got 9 by 8 q square and 10 to the power 11. If you divide, the capital T gets cancelled, or in other words you can say that these two are equated. So therefore 1 plus 2 root 2, and then it will be 9 by 8 into 10 to the power 11 q square, and this is 100 into 10 to the power minus 3, and small g for simplicity I am taking only as 10. If you keep all the values properly, we have q square as 2.32 into 10 to the power minus 12. I advise you to check these values. I was checking with the help of a calculator, although it will take a little time for you to calculate. So q is equal to root over 2.32 into 10 to the power minus 12. It is very nearly equal to 1.5 10 to the power minus 6 coulomb, and therefore it is 1.5 microcoulomb. You can approximately calculate and come to very near the answer also as per your intuition during the calculation.